Good morning. So let us continue with the theory of fire propagation. So we have seen several modules so far: basics, review of fundamentals like thermochemistry, chemical equilibrium, kinetics. Then we also reviewed the characteristics of premixed and diffusion flames. Then the burning characteristics of liquid fuels and solid fuels, where we saw how to ignite it, how the flame spreads over them, and the burning rate. Then once the fire is established, how the hot gases rise from the fire basically, and in an enclosure when it goes and impinges with the ceiling, how the ceiling jet propagates, what are the characteristics of this fire plume and ceiling jet, etc. We saw in the previous lecture. Now we will go to the 7th module where we will discuss about enclosure fires. So now typically we have a compartment or an enclosure, and we are not talking about the open fire now. The fire is occurring within an enclosure, and the boundary and the ventilation conditions, etc., the ceiling height, etc., will dictate the growth and the characteristics of the fire. So we will see about this, how the air comes in through ventilation, how the smokes go out, etc. We will see. So fire in enclosures such as rooms, compartments, or confined spaces, generally they are called enclosure or compartment fire. So the dimensions of the enclosed space can be as small as a closet, a single room, a bedroom type of thing, or a large hall. Or we can also talk about fire in a vehicle, aircraft cabin, etc., or in a space shuttle also. So wherever there is enclosed space, you will see that the plume dynamics, smoke dynamics, etc., are going to be extremely important, and the oxygen entrainment within the compartment is going to dictate. So there will be several factors which will control these fires. Understanding the enclosure fires requires a good knowledge of how ignition of materials occur, then pyrolysis of solid and liquid fuels, then fire dynamics or flame dynamics, basically the rate at which the fire is growing, etc. Then how the hot gases are propagating, plumes, ceiling jets also are included in this. Similarly, once the plume accumulates over the ceiling, the hot layers are formed. So that involves wall heat transfer, and due to the temperature differences and which causes the density differences, fire induced flow will occur. So these are all dictated by the vents, doors or windows which are there in the enclosure, and how much they are open, etc. That means several factors which we have discussed so far are required to analyze a enclosure fire. The objective of the study from a fire safety perspective will be to calculate the how much time it will take for the fire to grow within an enclosure, and within that time the people should be evacuated. Like within the growth, basically the fire can grow at a faster rate, but within the time it grows to a bigger fire, the people should be evacuated. Then the fire should be extinguished so that the structure will be safe. So to understand the growth rate of fire under several conditions within an enclosure is therefore very important. Okay, so a fire can start as a small fire, maybe gradually it may grow, but suddenly it may grow to a condition where it may ignite the subsequent or the neighboring materials, and that will give us a critical condition. which can cause maximum damage, and within the slow growth of the fire itself, the people have to be evacuated, and critical condition should not be reached. The fire should be put off within that condition, so that the structural failure also can be saved. So these are the factors which we will be discussing. So let us see some photographs of an enclosure fire. You can see enclosure. This is in the this is taken in a lab called Worcester Polytechnic Institute in USA. Now this is enclosure. You can see some commodities like a computer, a TV monitor, a couch, a bed, and some chair, etc. A small enclosure, and maybe there is a, you can see there is a dust bin which actually ignites and a fire establishes. So the ignition is counted only, the time t equal to 0 is counted only when a flame is established over this dust bin, and now after about 71 seconds you can see the flame is growing. However, other commodities are not ignited very much. Once you go to about 93 seconds, you see that the other commodities also are ignited, and the bed is in fire basically. So ignition where a sustained flame is observed, that is the time t equal to 0. Then the fire grows, okay, from that point to about 222 seconds, where you can see that it has ignited the other commodities, and more than one commodity is burning now. Now at a time instant of about 270 seconds, you will see 260 seconds or 270 seconds, you can see that all the commodities are ignited, and the entire, you can see at about 277 seconds, you will see fire from all the commodities, and the smoke, the fire actually goes out of the compartment also. Okay, so there are several stages. Ignition is the important first stage which will cause the fire. If it is avoided, it is good. Then the growth. Now in the growth stage, typically the fire alarm should be triggered within about 60 seconds, where you can see a visible flame, etc. But here also you can see that the smoke has not gone. So basically, when we are within about 70 to 100 seconds, if you detect the fire and evacuate the people and start sprinklers, etc., then the fire will not grow. But basically, if you are not able to sense it, basically there is the sprinkler doesn't work or the sensor doesn't work, in the case the fire continues. The growth stage is where the fire steadily burns, and it actually grows, the heat release rate grows, and after that it reaches a state, say between 222 to 270, you will see that the release of heat will be almost constant. Then flashover occurs. Basically, flashover is a condition where all the commodities burn, and the compartment now cannot be saved. It is a critical condition. Now structural damage also can be caused. Okay, now after this, where all the commodities are ignited, that is flashover. After that you get what is called fully developed fire. That means now the fire will always be contributed from all the commodities, and steadily it burns. That is, the heat release rate will be steady for some time. Then finally, after the fuel is over, then decay starts, that is, the heat release rate drops. So we will show about this. So ignition, accidental ignition where somewhere causes a fire, then the fire grows slowly. After some time, multiple ignition occurs, then the growth of the fire will increase when the heat release rate is such that, for example, you can see now In this stage, okay, there is no smoke layer, everything is visible. For example, WPA etc. is visible. Now in the around 93 seconds, you are not able to see the boards there. The top layer totally is invisible. It is smoke covered. Okay, these are the problems. So initially there is no problem. Here also in the around 71 seconds, yeah, some small smoke layer is seen, but visibility is not affected. But if you go to about 93 seconds, you can see that the visibility is affected. The WPA, the boards etc. are not seen. The top layer visibility is affected. Now coming to the, say now this continues for some time. The fire grows slowly. The heat level increases from 93 seconds about to 220 seconds. Now you can see that the smoke layer slowly descends down. Now nothing is visible. No letters or anything is visible. But due to the luminosity of the fire here, you can see some components which are not yet ignited are visible nicely around 222 seconds. So that means these are all the stages. Still the burning continues. Now you can see that the temperature of this layer compared to at about 93 seconds, the layer of the smoke at 223 will be hotter. For example, the smoke layer at around 93 seconds can be at a temperature of about 300 degrees centigrade. Here it would have reached 600 degrees centigrade. Once it goes to higher and higher temperatures, you can see that the smoke intensity also increases at around 260. Now the temperature also increases to 700 800 degrees. This high temperature and also the radiation from the full-fledged fire ignites all the commodities. Okay, so this is called flashover. A steep increase in the heat release rate occurs from this time to this time, and a fully developed fire occurs. This is called flashover, where you can see that all the commodities now burn. Here 261 seconds, these commodities are not even ignited, but you can see at 277 seconds, these are also under flame. Everything is burning, and the intensity of the burn is very high. Now the fire, the flame, the only smokes come out in this particular time period, but once flashover occurred, the heat release rate grows rapidly, so that you can see the fire itself comes out of the compartment. It is actually the open compartment, the front end is open, so maybe it's a door or something. So the entire fire itself you can see comes out of the, because of a very high intensity. But when you see that if you don't have this much opening and you have a small window, then the dynamics will be different. So the enclosure dynamic, fire dynamics is dependent on what is the open space. So for this, the air actually entrains from the open space. So there is basically no starvation of oxygen. Here also, in this case also, you can see that the air can come from the bottom side and the fire or the smoke will leave from the top side. Now the visible flame itself is seen. That means the fuel is carried away, very hot fuel air is carried away, and the fuel is burning outside the compartment in this case. Do you understand? So this is like this. Not all the fuel should burn within the compartment because it may not have enough oxygen. So you can see that the subsequent flashover causes lot of pyrolysis. The pyrolysis rate increases nicely. So all the commodity fuel gases come out of that, and this get some oxygen from this small area of, okay, here this small area, but the fuel, hot fuel, just goes out and auto ignites in the outside the compartment. So several species can be there. Now if you don't have this much opening, you will see that the growth rate may be affected. Even though flashover can occur, the hot fuel air will come out. Basically you can see the smoke coming out, etc., and so on. So the enclosure fire depends on several factors. What are all the flammable fuel load? What we can say? What are all the flammable materials inside the room? And when I say flammability of this material, including the ignition, fire spread characteristics, etc., then how much opening is there for air to enter in? Because for burning so much commodities, not enough air can come in at the required rate. So that is the reason why the fire is seen outside the enclosure also. Now, once flashover occurred, everything is now burning. A fully developed fire is there. Now, the heat release rate will be constant because everything is ignited. That is, the flame is over all the commodities. So, the burning rate starts. The burning rate, we have seen that it will normally be steady because all these are condensed fuels. Then once the fuel is consumed, then the decay period starts. So, stages we can say: ignition, growth, critical condition which is called flashover, then fully developed fire and decay. These are all the stages of a compartment fire. Now, graphically you can say heat release or temperature versus time. Okay, anything we can say. So, now ignition occurs. So, this is maybe a temperature of some pyrolysis temperature or ignition temperature. Ignition has occurred. Then the temperature increases. Now, you can see that it increases gradually. Once temperature reaches, the smoke layer temperature reaches a critical value, say 600 to 800 degrees centigrade, flashover occurs. That's it. So, this is the growth period. After ignition, the growth period is this. You can see that the growth period is non-linear. That is, the slope is gradual here. Then slope also increases in the growth period itself. So, this is non-linear growth period. If you say heat release rate or temperature, it varies as say T square, you can say T power n, that n tends to 2. So, T square, this is the growth rate. Now, after that, suddenly all the commodities are ignited, which will lead to a sharp increase in temperature due to flashover. Okay, now all the commodities in this period, very short period, you can see that the delta T is very low here, very small. Within a very small period, you reach a very high temperature or very high heat release. Now, all the commodities have flames over them. After this, a fully developed fire regime comes where the temperature is almost constant or heat release also is almost constant. Then the fuel from several commodities are consumed, only a little amount of fuel is left over. So, we can see the decay of this. So, basically we have to evacuate people within a short period. See, for example, the temperature of the maximum temperature in the compartment may be about 300 degrees centigrade. It is in the top layer basically. So, evacuate people within this time. Then put off the fire within something like this, so that we don't reach the flashover at all. Or at least if sprinkler etc. works, it will cool the surfaces of the burning materials such that the fire will not grow. It may not be fully extinguished, but it may not grow, and flashover can be shifted to the right. It may go like this. If you have sprinklers, it may grow like this, and a flashover can occur only after a particular time. So, you need more time for saving the people as well as structures. So, understanding this curve is extremely important. The growth of the fire, this is the growth stage, correct? This is the growth stage, developing or growing fire. This growth stage is extremely important, which is dependent on the flammability characteristics. Some materials, the fire growth in them will be very, very high. For example, if you take a couch made up of cotton material or any fabric material, the heat release rate there will be very high. But if you have say some wood type of furnitures, then the heat release will be slower. So, based upon the flammability, you can see that the growth rate will vary. At a particular time, there will be some amount of heat release only. The flash over condition is very tough to determine, the flash over condition. So, you can say that if the smoke layer reaches the hot gases which is accumulating over the ceiling, reaches around 800 degrees or 600 to 800 degrees, flash over can occur. So, that is the condition, but it may vary, based on the situation it may vary. Okay, so the intention of understanding these stages in a fire is to get this time required for the growth and well within that time evacuate the people. That is, the temperature should not exceed a particular value. So, see, for example, 200 degrees centigrade smoke layer goes, it may trigger a sensor, and the sensor can trigger a sprinkler and so on. So, if that happens, that is good. Even when the sprinkler is operative, the people should not be in the room. So, an alarm will be there. After alarm, there will be time lag within which the sprinkler will be operated. So, once alarm is sounded, then the people can be evacuated. But that does not mean that the structure will be safe. So, if critical condition occurs, then you can see that within a very short time, the temperature or the heat release increases to a very, very high value. That will surely cause structure failure. So, flame will be put off well before the critical condition. So, understanding this growth, which is dependent on, see, this growth period is critical for us. We do not want to operate in the critical condition at all. So, the growth period is dependent on the material characteristics, what are the type of materials you are putting in, the fuel load, etc. Now, how ignition occurs? Let us talk about the stages. Ignition and growth, these two stages we will talk here. So, ignition can occur by piloted ignition. So, for example, it may be accidental or it may be due to any spark, etc. Okay. Then some hot spots. So, something can trigger the fire in some particular commodity, or this may be due to some spontaneous ignition also. See, something is stored which can spontaneously ignite. We do not know why it is igniting, because some material, like we have seen that the oil soaked fabric can have spontaneous ignition due to some chemical activities. So, if something is stored in a confined room, okay, then spontaneous ignition also can occur. But anyway, this piloted ignition or spontaneous ignition will lead to a flaming combustion scenario. So, you will surely see a flame. A small flame now grows to a full-fledged fire. So, the fire grows within the ignition zone first. So, then the heat release will be able to ignite the other commodities. For example, if you see the previous series of photographs, you will see that a dustbin was kept very near the bed. Bed has lot of fabric materials. Once the dustbin got ignited, very soon the bed was also ignited. So, the small flame grows over the ignition zone and ignites the other commodities or other materials in the room. In the early stages, enclosure seems to have no effect. That is, when a small fire is there, the enclosure conditions will not have any effect, because the enclosure has some oxygen. For feeding the small fire, this oxygen is more than enough. Okay, but if as the fire grows or spreads, then you will see that there may be the effect of enclosure in the growth of this fire. Okay, so the early stage, just go back, we are talking about early stage like this, something like this, where the fire growth is almost linearly growing. Early stage fire, the enclosure will not have any effect. Fire spreads and ignites adjacent flammable materials. It may spread over a particular material, then adjacent material can also be ignited. Now the extent of fire will increase. Okay, go back here. Initially a small fire is there, then the extent of this fire has increased. That is the early growth stage. Till now we can see that there is no effect of anything, the enclosure, because normally the air entertainment is there, air comes in nicely and so on. So the flame rises, that means the flame extent increases and the plume will go and hit the ceiling. That is, laterally between the commodities the fire spreads. That is one condition. The fire rises or the plume goes and hits the ceiling. That means once it hits the ceiling, it may spread as a horizontal ceiling jet and a layer is formed there, hot layer is formed at the ceiling also. So this is another condition, that this hot layer can also try to heat up the materials in the enclosure. The hot gases rise upward because of the buoyancy. We have already seen the plume characteristics. And the ceiling, first we will say that there will be a smoke formation because of some soot particles, but it will be a light smoke, light grey smoke, because the inception of soot and its conversion initially will be nice, but if more and more fuel burns, and these are all unsaturated materials, hydrocarbons, so you will see that more and more soot incursors will come in and soot formation will increase. So initially what was seen as a light grey smoke, go back here a light grey smoke in the 71 second scenario, you will see that it has become more and more darker in 93 and 222 seconds. So the light grey smoke transitions to thick black smoke during the growth period. Similarly, the temperature of the smoke layer can vary. It will slowly increase and it may get into the range of 500 degrees to 600 degrees centigrade also. So once it exceeds this temperature, the smoke layer which is on the top can also radiatively heat the materials in the enclosure. Okay, so the ignition can be piloted ignition or spontaneous ignition, which causes a flame to generate or to incept. Then this flame or fire grows around the ignition zone and spreads over the other commodities or ignites other commodities. Okay, then the earlier stages the enclosure doesn't have any, because no, only the local flame zone is hotter, all the walls and ceiling etc. are not very hot, so it will not have any effect. Similarly, the oxygen in the compartment itself will be enough for burning that particular small flame. However, once the flame grows, that it spreads and ignites the adjacent flammable materials, you will see that the enclosure effect will come into play, because the enclosure walls can become hotter. Similarly, the fire rises up and interact with the ceiling, and that means that the ceiling also become hotter, and the hotter gases which has the carbonaceous particles, soot particles, will lead to smoke formation, and initially the smoke will appear as a light grey smoke and it will accommodate over the ceiling, accumulate over the ceiling. After it accumulates over the ceiling, basically more and more soot will be formed and it becomes thick black smoke. Okay, the thick black smoke, temperature will increase gradually. Once it reaches temperature beyond 600 degrees, radiative heating from that layer to the commodities will occur. So this is the ignition growth period.